Hello, in this video we're going to talk about evaluating limits. This one's going to be method 2, which is to evaluate limits by factoring and canceling. Now in a previous video we tried to evaluate this limit by using the direct substitution, and if we tried plugging in 4, we got 16 minus 16 over 4 minus 4, which gave us 0 over 0, and that was bad because that's not a real number. But does the limit exist? In this case, it will. We just need a new method, and that's factoring and canceling. Okay, so let's do exactly what the name says. Let's factor and cancel. Now, why are we having a problem? Well, if we got 0 on top, that's fine. It's because we're getting 0 on top and the bottom. So x minus 4 is giving us 0 on the bottom. Okay, so our goal is to cancel that x minus 4. So does x minus 4 factor out of x squared minus 16? It does, because that's a difference of squares. So when you factor x squared minus 16, and you get that, then you notice that these will divide out. And what you have left is the limit of just x plus 4. Now we're back into the direct substitution. What happens if we were to plug in 4? Well, that's fine because 4 is in the domain of x plus 4. We're just going to get 4 plus 4, and that is 8. And that's how easy factoring and canceling works with limits. Okay, example 2, we have the limit as x approaches negative 3, and we have this rational function. So you're going to do method 1, which is the direct substitution. Just plug it in and see what we get. So here we're going to get negative 3 squared. That's 9 times 2 is 18. Then we're going to get minus 15 and minus 3. On the bottom, we're going to get 9 minus 9. Well, on the top, 18 minus 15, that's 3. Minus 3 is 0. And on the bottom, 9 minus 9 is 0. So this is bad, but in a way that it's actually good too, because 0 over 0 means there's still a chance a limit exists. So let's go ahead and see if we can factor and cancel. Now, you'll probably hear me say this quite a bit. One of the hardest things about calculus is algebra. A lot of things people forget, like in this case, factoring. It's going to make the calculus seem hard, but it's really just the algebra. So we need to factor the numerator. All right, so that's going to factor as 2x minus 1 and x plus 3. Then the bottom, we get x plus 3, because it's a difference of squares, and then x minus 3. Now, why is that good? Well, what was giving us the problem on the bottom was the x plus 3, right? Because if you plug in negative 3 into x plus 3, you're going to get 0. Well, then our hope is that we would get an x plus 3 out from the top, because again, we're getting 0. Notice that those two will divide out, and that will leave us with 2x minus 1 over x minus 3. So now let's see what happens when we plug in negative 3. We're going to get 2 times negative 3 minus 1 over negative 3 minus 3. That's negative 6 minus 1. That's negative 7. Now on the bottom, we get negative 6. So our answer is 7/6. So here's our final example. We have the limit of x to the 4th minus 1 over x cubed minus 1. I think you can quickly see we're going to get 0 over 0 when we plug in 1. So let's try factoring and canceling. Now the top is it's a 4th power, but it is a difference of squares. It factors as x squared minus 1 and x squared plus 1. On the bottom is a difference of cubes, which factors to x minus 1, and then x squared plus x plus 1. So you're going to have to remember how to do all these factoring. Now, here's my problem on the bottom, right? I'm getting 0 on the bottom, and it's because of this. When I plug in 1, I'm going to get 0. So my hope is that I'm going to get an x minus 1 from the top. I don't have one yet, but notice that if I plug in 1 here, I'm going to get 1 squared minus 1, that's 0. But it's also a difference of squares. This can actually factor again. So x squared minus 1 will factor to x minus 1 and x plus 1. And then you get x squared plus 1, which does not factor, over, and then again our x minus 1, x squared plus x plus 1. So our problem was the x minus 1. They do now divide out, and we're left with x plus 1, x squared plus 1, over the denominator, the stuff that's left over. And now we're back to our direct substitution. What happens when we plug in 1? We're going to get 1 plus 1. Okay, that's fine. We're going to get 1 squared plus 1, also fine. And on the bottom, we're going to get 1 squared plus 1 plus 1. That's going to give us 2 times 2 over 3. So our answer is 4/3. All right, I have some examples up on the screen right here. I want you to try each one, and to find the solutions to these suggested problems and more information about NIU, please follow the link down below. Good luck.